Okay, so today on 5-8 we're going to focus on one thing, and this is a calculator problem. It's about polynomial models in the real world. Should probably move this closer. Okay. So you're going to receive a graphing calculator and an instruction sheet. You already have your instruction sheet. I'll get your graphing calculator to you in a moment. Before I do that, I want to talk about what it is we're doing. So, and ignore, that's last Friday. This was from last year. How about learned and yesterday's? All right, so we're not going to have time to write in our math journal today, so just work with me here. So yesterday we took a binomial and we expanded it to a power of n. So we had a plus b to the nth power. And we did something called binomial expansion, where we used Pascal's triangle. So if you were absent yesterday, you've got that video to watch. You've got some work to do. It is very different, and you're responsible for it. It will be on the test. So it wasn't hard to do, and it was actually sort of fun. It was like a puzzle, a math puzzle. But what we did, in essence, let's say you didn't know any of this about the expansion rules. What would you do if you had 2x plus 3 cubed? Hand, work with me. So what you would do, if you didn't know any of this, you would have gone 2x plus 3 times 2x plus 3 times 2x plus 3. And you would just have to work them, FOIL this out, and get the trinomial, and then distribute that 2 across the trinomial and the 3 across the trinomial, and then you get another one. Well, what would happen if you had a power of 6? You wouldn't have enough paper. You know, it would take 5 or 6 sheets of paper to get through all that, and a lot of time. So yesterday we learned how to expand binomials using Pascal's triangle very quickly and efficiently. Okay, and if you've passed your homework forward, good. I'll pick that up in a moment. What we're going to do today is work backwards from that. What if somebody gives us an equation, a big polynomial, and they say, well, what binomial to a power of n, what was the power of n, and what was the binomial that created this? What was A, what was B, and how many powers was it? To what power of n? Okay, this is where we're working now. Well, what would we have to do to figure that out? If we have a long, 7-term polynomial, we would have to work backwards to get to that A plus B to the n, right? Well, yesterday we expanded to work forwards with it. Today, to work backwards with it, we call it a regression. So today we're going to focus on regressions. And there's 3 kinds that we're going to work with. We're going to have a linear regression. We're going to have a quadratic regression. And we're going to have a cubic regression. Okay. All right, so these will be done on the calculator. And what we're going to do is, they're not so much giving us a quadratic or a polynomial to work backwards from. They're going to give us some points, some xy coordinates of several points. And they're going to say, well, what created this? Was it a linear equation, a quadratic equation, or was it a cubic equation? And what we're going to have to do is work backwards with each one of those, a linear regression, a quadratic regression, and a cubic regression, to see which one fits those points. We'll graph each one, but which one fits these points the best? And whatever graph fit those 3 points or 5 points or however many points they give us, whichever one fits the closest, we'll say that's the equation it came from. We're guesstimating this is going to be it. We're estimating. So let's look at what's involved here. So to begin, I will give you a calculator, and notice that you've got a set of instructions at your desk. Is there anybody without this set of instructions at their desk? Okay, it's going to start with this. Okay, so it says calculator instructions for section 5A. You will have this on your test also, because this is on your test. You'll have one question like this. So when you get your calculator, you want to power it on and clear everything out. All right, to do that, you want to press the your clear button to clear anything off the current screen, and then you want to do your second function, quit out of anything if you're inside anything, quit all the way to the main screen, and then press clear as needed. Okay, so let me show you with mine. Let me turn it on. I've got stuff in there, so let me move this down. I'm going to quit, so second function, quit, and now I've got stuff on my screen still, so I'm going to clear it. And don't forget that we need to reset everything, so we are starting fresh, and there's nothing hosed up that's going to mess us up in our calculations and cost us a problem or time. So what you want to do is clear your memory, so second function, mem, and then 7, 1, 2. That clears your RAM. The next thing we're going to do is reset all the defaults. Second function, memory again, and 7, 2, 2. And it reset all the defaults. So everybody should be starting the same way. There's an exception of one calculator that's the one that was missing, that I was out there joking in the hall about, that I set it down somewhere and forgot where I set it. I am now losing my mind. Okay, so I'm going to pause the video and pass out calculators now. As soon as you get it, clear everything out and get ready to go. Okay? Okay, everyone has a calculator now, and we're going to begin. So the first thing we want to do is, like I told you, back out of everything, clear and quit, quit, and clear till you're back at the main screen and it's empty. At that point, you want to clear your memory and reset your defaults, and I'll give you like 10 more seconds for that. Please pay attention. Okay, is there anybody who needs help doing the first part? All right. I'm going to skip over this for now about resetting the window. This would be if you're in the middle of a big problem and you don't want to erase or reset your RAM or reset all the defaults. This is a way to go back in and reset your numbers for your window view, like for your graph. And let me show you. Just watch up here. Don't do it on yours. But you would go press your window, and I put these on here because you're going to have this on your test day. So if you host something up so badly, you've got to know to go here and follow these instructions. Hit the window key, and notice there it is, window. It says your x minimum is -10, your x max is a +10. What this means is on the x-axis, whoopsie, on the x-axis, it's starting at -10 and it's going to go to a +10 with 0 in the middle. Right? Now, the next thing it says, whoops, there we go. The next thing it says, this x scale is 1, so it means every unit counts as 1, 2, so every tick mark is 3. If you wanted it to go by 5s, then you would change the x scale to 5. If you wanted to go by 2s, then you'd change your x scale to 2, and so on. But this is x scale is 1. Now, we repeat the process here for the y values. The y value, it says the y min is -10. So here's my y axis. And it's going to start on the screen at -10. And the y max is a +10. So you notice all the way around it's going to 10 units up and sideways each direction. The y scale is also 1. And you could set different scales for your x and y if you want. So each one is 1. Now, the last one, I'm not sure what it is, and I'll find out later. I've never had to use it, but just know that the default is x res = 1. All right. So that's how you reset if your graph is way off screen or you can't find anything. And I'll show you a quick way to reset your graph in just a moment. All right, now let's do our work. I'm going to quit out of this. To get out of this, you just go second function and quit. And that's how you get out of anything that you want out of. Okay. All right, so if you'll follow along with me on your paper, this is on the first page about halfway down. It says page 353, enter an x-y t-chart into L1 and L2. Okay, so what we're going to do, we've got this XY t-chart right here, X and Y. So they've given us 1, 2, 3, 4, 5 coordinate points to work with right here. 5 coordinate points. So these are our X values, these are our Y values. Okay? So we're going to enter all these in something we're going to call it L1 and L2. All right? So to do that, we're going to start off by pressing the Stat button right here, 2 to the right from the alpha, the green button. It's a Stat. Now you want to select 1 for Edit. And there they are. There's your L1, L2, L3. So if you don't see L1, L2, L3 at the top, raise your hand and I'll come help you. That was the problem with the calculator that's sitting up here on number 16. All right, now on L1, we want to enter all the X values. So look at your chart right here, and you've got 0, 5, 10, 15, 20. So let's start by doing that. Type 0 and enter. And it put 0 in the first L1 element. Now 5, enter, and it just goes right down the line. 10, enter, 15, enter, and 20, enter. Okay, 0, 5, 10, 15, 20. Verify that that's the numbers. Those are the numbers on your underneath L1. Is everybody good? Anybody have any issues and need help? All right, now right arrow over, use your cursor arrow to go to L2, and now type those Y values, 10.1, 2.8, 8.1, 16.0, and 17.8. Enter. All right, now we've got everything that we need. Verify that your numbers are correct. So for L2, it should say 10.1, 2.8, 8.1, 16.0 just turns to 16. That's okay. And 17.8. Okay. Is everybody good? Anybody need help? All right, so this gets us through that first part, so let's quit out of it. Second function, quit. So now, how can we solve this real-world situation using our data set? Well, how can we find an equation that matches these points? Okay, they need it in the statistics department so they can do predictions, right? And forecasting for next month's sales or something. So we have to start using the regressions to work backwards from these and find an equation that goes with this set of data. So to see our data points, though, let's see them physically on the screen, like on a plotter. So we need to turn on our stats plots. So what you want to do is go to Stat Plots by doing second function, y equal, and you'll see there's stats plots, or stat plots. And you want to go down till you see plots on. There it is, number 5. And you can either type the number 5 or you can just press enter. Make sure when it says plots on that you press enter one more time so it says done. If it doesn't say done, you haven't done it yet. Okay, does everybody have plots on done? Raise your hand if you have plots on done. I see about a third of the people, so I'm going to pause the video and come around and help. Actually, aisle buddies, check across with your neighbor and see if they have it. If they don't, help them. If you don't have this, you can't do the problem. Okay, so everybody's there and we've all got our plots on. Now what that's going to do is when you look at your graph, you're going to see little circles where these points are. Okay, and what we're going to do is using this table, we're going to find the closest linear equation to these dots and see if it passes through any of them. Then I'm going to have it do a quadratic and see if it passes through any of them. Then we'll do some kind of cubic and see if it passes through. See which one came the closest. That's what we're going to do. So now we've done this. Now let's move on. And if your calculator goes off, just hit the on button again and it'll go back on. So we've turned the plots on, so when we graph it, we can see those dots. Now, later on, for some reason, you might want to graph and not see those dots anymore, so you would turn them off. Don't do this yet, but I'm just going to show you how to turn them off. You would go second function, back to stats, plot, and see number 4 says plots off. You would just press number 4, press enter, and that would turn them back off. But I don't want to turn them off yet, but that's where you do it. Now we're going to get our formulas for linear, quadratic, and cubic regression. We're going to graph them one at a time and see if they match the data points. So let's do the linear regression first. So I'm going to clear my screen to get it all nice and clean, and we're going to press stat right by to the left of your arrow keys, your cursor keys, I guess you call those, cursor buttons. So now we want to right arrow over to calc. See, edit is highlighted. We want to go to calculations, right? And what do we want to calculate? Well, I said we want to do a linear regression. So look down. There's 1 is 1 variable statistics, 2 is 2 variable statistics, 3 is median, 4 is linear regression, AX plus B. That's the winner, number 4. So you can either arrow cursor down to it, or you can just press the number 4 on your number pad. Notice that it will come up and say lin reg AX plus B, and you want to press enter. I have pressed enter twice on here. I don't know, I'm on a simulator, so your calculator you might have to press it one more time. I'm not certain why that was there, but we had to do it that way last year. May not be the case anymore. Now, and it doesn't hurt to hit press enter twice anyway. So now what it has done is it's returned the equation, the A value, and the B value. Okay, so think about what a linear equation is. Y equals mx plus b, right? That created a line with the slope and the y-intercept. Remember that? So what did they turn to us? They've turned back to us y equals ax plus b. That's still a line, but our m is now a, right? So they tell us for this set of data that you gave us that the a value should be equal to 0.572 and the b value that you gave us should be 5.24, and this is what they've calculated. So for this equation, if we want to see the graph now, we're going to go to the y equals and type, let's see, a is, so 0.572x plus 5.24. See, replacing A and B with the values they calculated. Everybody see that? But there's an easier way to do this. That would actually be a pretty easy one to type in. But in the others, there's like 10 decimal places on all of them, so it would be brutal to try to type all that in. So I'm going to show you just how to transfer this now into our graph. All right, into the y-equals. So now to graph this, we're going to transfer our regression to our y-equals. So go to y-equal and clear. If there's anything in your y1, clear it out by hitting the clear button. Now press the vars, the variables key. It's V-A-R-S. Press that key. And press number 5 for statistics. Now, the statistics, we're going to get the equations. So go over, right arrow to EQ. And we're going to use the first one, regression equation. So number 1. Now, there it is. We just transferred all that data into our y-equals. Everybody see that? So there it is. y1 equals 0.572x plus 5.24. That's what we just calculated, right? Now, hit your graph key. And look what it did. We've got 2 plots. See the little circles? There's our plotted points. There's 2 of them anyway. And that line just took its own course and didn't touch any of them. So I would say it's a pretty bad fit. Probably not the one we're going to pick. But maybe I'm uncertain. Maybe nothing shows up and I need to change the view of my zoom. So to zoom out or to zoom to fit, here's how you do that. Press your zoom key and go down to where it says zoom to fit. There, whoops, there it is at 0. You could just press zoom 0 and it would take you there. It's going to recalculate and redraw your screen, repaint it. It didn't make much of a difference to zoom it, right? So it's pretty obvious this one's not our problem. This isn't going to be it because see, there's a point, there's a point, there's a point. It's not touching any 3 of those. So what you might do if you were doing a test or homework, I would just sort of quickly plot it. I've got a point there, one there, and one up here, and I've got a line that did this. So I would do that, and it's obvious it's the linear because it's a straight line. That's my linear regression. Okay, is everybody with me so far? All right, now we're going to repeat the process so it gets easier and quicker now. So let's do, let's zoom back out. To get back out of this, you're going to press zoom and 6 because see 6 is standard. So it's going to take us back to the original thing. So zoom 0 will zoom to fit. Zoom 6 will take you back to standard. That's the quick way to reset your defaults that I was telling you about earlier. Like you can type in specific numbers or you can just use those functions, the zoom functions. So now let's check our quadratic regression. So this one will go faster. So now we're going to press, clear and clear. Now press your stat button again. And now we're going to go over to calculate, calc. And this time we're going to do not the linear but the quadratic regression. So press 5, enter. And there's our values. Now let's transfer the data. So y equals, and now we're going to, clear out what's in there. You got to clear it out first. That's from the last equation. Now press your vars key, variables, and 5 for statistics, and then over 2 for equations. Press 1 and enter. And that is humongous. I don't think that's correct, but we'll see. Now, graph. Well, I guess that was correct. That is a quadratic right there. So you see, I wouldn't have wanted to type that in. No way. That's why we transfer it over. Okay, you could do it by hand, but why when you can just transfer it? All right, so back to the graph. Now we see we've got a little better fit this time, right? It looks like, let's do a zoom to fit. Zoom 0. Sort of close. So we had a point there and a point up there, and it looks like it got pretty close. You know, it's better than the linear, agree? But still, let's see if the cubic isn't even better than this one. So now reset your zoom, zoom 6, and quit or clear. All right, now let's do the last one for our cubic regression. So repeat the process this time. We're going to press Stat once again. And now go to Calc and cubic regression, number 6. Enter. And there's a lot of numbers I wouldn't want to type. Right? So now let's transfer it over. So y equals, and clear out what's there. Press your variables. And 5 for statistics. And now right arrow over to get the equation. Now press 1 for regression equation. And enter, and hit your graph key. Now let's see if this doesn't match any better. So far we've got 2 for 2. Let's zoom out and see if it looks any better. So zoom 0. And it didn't show a lot more. We could move this around and change values on that table that I showed you from the beginning about the x and y values. But actually this one looks perfect. This one fit every point perfectly. So I would say the best fit for us would have been the cubic regression. Okay? Does everybody understand what we did here now? We took a set of points. We took those points and worked backwards using regression functions in the calculator to see which one fit that data the best. A linear regression, a quadratic regression, or a cubic regression. And we decided that the cubic regression was our best fit. Okay? And that's what I had here. The cubic regression seemed to be the best fit. So do you see now how to calculate equations from given points and create equations that match the data? Okay, the one that matched your graphed points or your plotted points is the equation for that data. If the graph did not match the data points, and we also call those data points sometimes on a scatter plot, right, then it's not the correct equation. So that's it. That's all there is to it. And you're going to work a problem exactly like this. And in fact, right now I'm going to give you your review question from your study guide for the test. And, oops, wrong one. And I want you to work this problem and then you'll get it again when we get the study guide. Okay, so here it is, 5-8, problem 1. And that's all we're working out of this section. So here's your problem. What polynomial has a graph that passes through the given points? So you're going to take all your x values and put them in your L1 and your y values and put them in your L2. And then you're going to run the linear regression, the quadratic regression, and the cubic regression. Okay, so the x is going to be -4, -1, 2, and 3. And then our y values are going to be -51, -3, 27, and 61. Okay, so using these points, you're going to repeat the process and tell me which is the best fit for this set of data. Okay? Any questions? All right, so that concludes our lesson. I'm going to let you finish out the hour working on this, and you'll have the set of instructions for your test, so just know how to use them and to migrate to them and how to work this. Okay? You're awful quiet. Are you sure you have no questions? All right, this concludes our lesson today. Thank you.